Now, is the chair here for the next session?
I'm here. This is Carrie. I'm Carrie King. I'm chairing the next session, in which I believe we have all three of the speakers in the schedule. There are 4 speakers listed, but we do not have the 4th listed speaker in the original schedule. But we do have 3 of the speakers from Krakow University. So this is the triple Poland session here. The first one will be 30 minutes and the next 2 will be 20 minutes. So the first person is Marcin.
Yes, I'm here, Marcin Jedrzejczyk. It's difficult to spell for foreigners, I know it. I can help.
Yeah, Jedrzejczyk. So are you looking for the ability to share slides?
Yes, I can try.
So yeah, so Alice or Anwit?
Yes, let me know if everything's okay with the slides.
I see it now.
Okay, but I wanted to have a full screen also. I think it's better now. Do you see the full screen now?
Yes, it's good.
And I would say go
Perfect.
ahead. I will I'll let you know. You have 30 minutes. I'll let you know when you have 5 minutes left.
Okay, thank you. It's helpful. Thank you very much. Dear Professor Chairman, dear professors and audience, I'm really honored to be here today with you because it's the first time I have the opportunity to be here on the conference that is interdisciplinary. Basically, I often attend to accounting and economic conferences. So this here on Thermodynamics 2.0, it's a very good opportunity to speak from a different point of view. I'm a professor of economics and accounting from Krakow in Poland, and as you mentioned, we have today we have 3 papers to discuss on, and I'd like to start with my paper, which is about capital work and economic value in the context of the first and the second law of thermodynamics. So first of all, I'd like to present the agenda. So I'm going to speak first about thermodynamic nature of capital, which is the most important category in economics. Then I'm going to speak about the economic constant that was discovered in Krakow by Professor Dovija and the model of capital. And then about the constructiveness of this theory on the example of human capital calculation to assess the fair wage, fair remuneration. And afterwards, short conclusions and recommendations, and eventually some questions if you would have any. So let me start with the very important thing for the accountants. We have main principle in accounting that is called duality principle, in which we have this basic equality between assets and liabilities and owner's equity. So basically we can say that this is, other words, assets are equal to capital. Assets are heterogeneous, so they could be either tangible or intangible, and the capital is abstract and homogeneous. So we can say that comparing it to the nature science, natural science, it's like the matter-energy paradigm. So basically, we have some parallel system here, and I'd like to speak more about the capital here because we understand capital in this science context as the abstract and potential ability of an object to do work. So it's really important because all of the assets also have this abstract potential ability, and you have to understand that in this context also people, like human beings, have the same ability of doing work. So they also have some capital. We call them in economics the human capital. So to say it more strictly, I would say that we have, on one hand, potential capital that during the work process, which is a dynamic and orderly and measurable transfer of capital to work objects, we create value that could be embedded in products. So basically we have this triad. Capital, the first element. Second is work as a dynamic process. using this potential ability of doing work. And third thing is the value that is created, like and this, let's say, concentration of ability of doing work in this particular asset, let's say, or particular good that has been constructed or produced in economics. So this is so-called natural triad that I'm going to use. So if you can see, we have this table in which we have the most important economic categories here. So as I was trying to mainly to discuss here capital, work, and value, but I'm going to speak also about money, assets and resources, but very, very shortly. How we can speak about capital in a science context? First of all, as we can see from this basic accounting equation that was firstly introduced and published by Luca Pacioli in 1494 in his very famous book. I'm going to show the book at the end. This is this equality that shows us that capital does not arise from nothing, and this could be treated as the analogy to the first thermodynamic principle, right? So that's why I'm going to focus mainly here on people. And but first, I'd like to comment on capital, because capital undergoes a spontaneous destruction that is understood in accounting as asset depreciation. So assets are losing value in time. So this is the second law of thermodynamics clearly revealed here. That could be also verified in the field of research on work and remuneration for work done. So like Peter Atkins did, we can treat the human body as a heat engine. So this heat engine basically could be understood also like we are transforming some energy, and we also can take something, or we can basically we have good results from the difference in temperatures we can see in our life, because for instance, when we eat something hot, we like to have a cold drink afterwards, and when we are in sauna, we then use the cold bath. So we have two different, let's say, heat sources, right? So hot and cold. So what I wanted to stress here is that from an economic point of view, the most important conclusion here is that this person lost capital must be compensated. So this is a compensation, let's say, which directly leads us to the creation of a theory of remuneration. So the next paper of Yuri Renkas will show the calculations of this fair remuneration basing on the human capital model. Let us go further, because you can see a lot of definitions here that we are using in Krakow, in Poland, to show this science in economics. But what is very important is this economic constant that is the last row here in our table, because the statement about the existence of a constant is very binding and requires more explanation. So basically, this is the process of capital flow in the commodity and money economics. And as you can see, there is a composition of human capital, forces of nature, and assets, because when we want to produce something, first we want to use our ability of doing work of humans. Then we have some assets to be transformed to another assets, let's say. So materials are transformed to the finished goods. And we have also the forces of nature that helps us to perform this work. So we have in the second here, work and wage productivity, because every action needs wage productivity here. And we have then two flows. We have products of work, so these are finished goods, let's say. And on the other hand, we have wage receivables, because this is this consequence of a production process. So so we have this exchange that happens in economic system, that means that exchange of receivables, in other words, money for products that were produced. So I'd like to draw your attention to Albert Einstein's statement, and he said that compound interest is the greatest mathematical achievement of humanity. So one could ask, is it a joke really? But for us, for economists, I think that it is not a joke, and this is the basics for future research, because a nature researcher, as you can see, should look for the source of the interest, because there is this phenomenon. So we believe that the share of the nature is determined by the economic constant that is equal to 8% a year. So this was confirmed on many papers here. I think it's more than 20 years we are doing the research on this. It's also stated in my abstract, so it could be also cited here. So the thing is here that people get a fair pay, and asset arises as to the source of this surplus. So basically, this interest, in this interest, we have to take into account the forces of nature, right? So this is this economic constant. And now I'm going to speak more about this constant, but using the model of capital here, because we start with the general model of capital, and I'm going to transform a bit this model, because this general model can be seen here. This is of course continuous capitalization. So we have the CT, which is capital in value in time t, and C0, the value of capital, sorry, not capital, but capital at the beginning. And of course here, what I really want to say is that this is very famous formula, but we want to change a bit, because the capital is not created from nothing. And here you can see this, because C0, it means that we have to have something on the start to continue the capitalization. So theoretical inquiries and this research has been conducted by Professor Dobija. He's going to speak as a third person today. And this rate R that represents here the rate of for the capitalization purposes consists of three components. And you have P minus S plus M. So I'm citing this is citation from Professor Dobija paper, where S is the average value of the random variable determining the spontaneous dispersion of capital. M means capital inflow through labor, so directly through labor, and P is this economic constant determining the rate of potential capital growth. So basically we have this this equation that, after combining these two models, we received CT is equal to C0 e exponent minus ST, MT, and PT, with P equal to 8% in the year context. So we have the first factor that is determining the spontaneous dispersion of this capital, and what is important, it means here the process defined by the second law of thermodynamics. Then we have MT that indicates interaction weakening the thermodynamic arrow of time and strengthening growth thanks to the transfer of capital through work and management, which is also important for management in economics. So this is also a discipline in economics management. And then PT, which is the factor that determines the natural potential for capital growth, that is a property of nature. So this is constant potential growth. As I said, after our many years of research, this is 8% on a yearly basis. So basically, going further, we can say that basically we need the inflow of capital through labor. and this mainly reduces the dispersion of capital. So, for example, parents keep their children healthy and economically balanced, but they cannot create a supply of life forces, talents, and health. So according to this model that I presented on the previous slide, an infant coming into the world would soon die under the influence of capital dispersion. And of course, it's prevented by the work of parents and society, which could be understood as this M, right? So we have now the model, the derivative of the model, that it could be treated as the formula here on the screen for measuring human capital. So human capital is basically the sum of capitalized living cost, capitalized cost of professional education at the interest rate, and the last of this sum is capital from experience. So basically what we need in human capital calculation is the value of cost of living, cost of professional education, depending on the situation. Of course, after the worker have some experience, the human capital value is growing because of the experience that grows in time, of course. So this model allows to understand the nature of profit and its sources. So I'd like to show the book, which is that is very important for economists, because this book reveals the discussion. It solved the problem of sources of profit. It's a Knight book, Frank Knight, Risk, Uncertainty, and Profit. So he just discovered that we have to spread between risk and uncertainty. He distinguished risk from uncertainty, and this was the step in right direction. And then uncertainty is the effect of the second law of thermodynamics, and the periodic profit is therefore the capital increase, which could be named as in the growth of capital. So periodic profit could be then defined as follows here. So we have C1 minus C0, and of course we have our previous models to be helpful here. And what is really, really important, first law of thermodynamics, profit arises under the condition of initial capital. So we need initial capital to have profit, and as we said, it doesn't not arise from nothing, and capital is naturally dispersed, and it is reduced by the work. So of course the worker during this process needs to have some premium, and this premium is called remuneration, and it should be fair, of course, after and this model allows us to calculate the fair remuneration. So as has been said here, we have also the fixed constant P here in our model 5. And what is really, I think, what is really important, I'd like to draw your attention to the practice, because this model could be used in order to calculate the theoretical wage of an employee. And let me show you the third step of the research, which title is Constructiveness of the Theory on the Example of Human Capital Calculation and Fair Remuneration. So in this frame, I am presenting the actual pay, my actual pay. Why I have chosen my own example? There are several reasons. First of all, I have direct insights into data. So this is my example. I have also the insights into data of Polish cost of living and cost of professional education. So I can reveal here that I'm 39. So basically, this is my total pay. I'm 9 years after PhD dissertation, and I have been consuming my cost of living by 28 years. So let us see. One more comment, which is really important here in this case, is that this pay from the Polish conditions, I treat as fair. What I mean by fair, I mean that I have 2 children, so I have 4 persons family, and without any problems, I can live in Poland, and I don't have any problems with, let's say, living here. So I think that this is a fair pay. And using the model, it is, let's say, a bit less complex than model number 5, but we have this sum. Cost of living, education, and experience. I'm going to calculate the theoretical pay, my pay, using the human capital model. So I have monthly costs of living, and this is calculated at the level of social minimum in the family of 4, which is 900 zloty, which were capitalized for 28 years to obtain the PhD degree. The data comes, of course, from the Polish Institute of Labor and Social Affairs. The monthly cost of education, as you can see here on the slide, was estimated at 1,500 zloty and were capitalized for 9 years, so from the time of PhD dissertation. And that, from this, we have 2 numbers, which you can see on the screen. 12, of course, means 12 months times 900 in case of K, and then we calculate the capitalization, which is constant, of course, and then the education costs, and then 11 years after reaching the PhD degree, so from the 28th year of age, my year of age, the experience, we have the experience growth factor, and we calculate this as 0.3. So 1 plus Q, 11 years, we had 0.3, so we have 1.3. So human capital value after 39 years, calculated on the with the use of human capital model, is 788,303 zloty, and then we impose the 8% constant here, and from this we have on the yearly basis 143,064 zloty, and divided by 12, the theoretical pay is 11,922 zloty. So let us compare now. We have the real exact salary, which is, let's say, around 11,000 zloty, and theoretical one that is 12,000. So I can comment that this difference indicates that the use of the constant of nature, P, 8%, which determines the average rate, as you can see, of lost human capital of an employee whose body acts as the heat engine, leads to a reliable description of reality. So I'm using the Gleiser citation from 2006. This is very important. I can read it because I think it's very important from the point of view of this research. What if we look at science as a narrative, a description of the world that has limitations based on its structure? The constants of nature are the letters of the alphabet. The laws are the grammar rules, and we build these descriptions through the guiding hand of the so-called scientific method, period. To say things are this way, to say the things are this way, because otherwise we wouldn't be here to ask the question, it's to miss the point altogether. Things are this way because this is the story we humans tell based on the way we see the world and explain it. So the theory of capital presented in approach that I'm trying to present here is the example of progressive theory. So the core of our theory is, from the point of view of Lakatos' approach, is the theory of capital. So the capital as the potential of doing work, so potential ability of doing work, and the theory of labor productivity parities were created on its basis. So this allows reliable translation of economic values, primarily wages. What I'm trying to say here is that what we can understand as labor productivity parity. In economics, we say that macroeconomic productivity of labor, Q, is the quotient of GDP and labor cost in whole economic system. So if we calculate this, we get, let's say, about 4 in the US and 2.06 in Poland. So this is this wage parity, this is this productivity, this wage productivity parity, and we can use it to translate the values from one currency to another. And I would like to draw your attention to this example in which I'm aware of the time, Mr. Chairman, so I'm getting to an end, but this is very important. If we use this macroeconomic wage productivity parity, we have 2.06 in Poland and 4 in the US. So let us use this Polish theoretical wage of the professor, which is nearly 12,000 zloty. After imposing the wage productivity parity, we get about 6,140 in the US. But as is worth stressing, this results from the generally known principle of minimal acting. So I'm using the minimum cost of living, not the average. So this is minimum cost of living. So this can be understood as the minimum fair
5 minutes
pay of a professor. It could be, of course, higher. Yes. So under the conditions revealing the talent of the person and intellectual capital of the organization, we have to say that Krakow University of Economics is, of course, not that high as it's very, very low in this context as, let's say, Oxford University. So, of course, this pay in the Oxford University would be considerably higher because of the intellectual capital of the organization. So we need to understand that this is really, really minimum here. What is worth stressing, these parities can be also used not only to remuneration, fair pays, but also to other economic values. So let's say assets value. Why I say this? Because exchange rate, which we all use and know, is not applicable in case of assets. Why? Because we are still trying to use another media to translate values. And the first example is Big Mac currencies, which the economists publish all the years. So you can see that in January 2020, this is worth 1.94 zloty per $1 based on Big Mac. And I've just noticed that according to this macroeconomic wage productivity parity, we have near 2. So it's very, very near to the Big Mac currencies. And I was doing a lot of research about the exchange rate in case of assets and the whole financial statements. And I found a lot of counterexamples that has shown that this applicable exchange rate, market exchange rate that is nearly 4 zloty per $1 this year is totally inapplicable in case of assets and financial statements. So I'm going to an end, and this is very important that what we were being discussing here. So this first and second law of thermodynamics that we are using in human capital model leads us to different notions, and we can say that it allows us to create a science in economics, because I think that this basics for research in economics could reveal the new opportunities of economic theory. And I believe that in Krakow, our team is trying to take advantage of this research. And to end, as I said, I'd like to present on the last slide, thanking you for your attention, the Summa di Aritmetica Geometria Proporzioni et Proporzionalità. This is the book published by Luca Pacioli in 1494, in which he introduced this duality principle, in which he distinguished assets that are heterogeneous from homogeneous capital, abstract capital that is in these assets, and as I said, could be described or could be compared to matter energy paradigm. So thank you for your attention.
Okay, thank you. I think we'll switch to the next speaker. I think people have questions related to very long-winded answers about what is capital and how do you think about it. So since you're all part of perhaps the same group, I think maybe we'll not get into that question now.